All right, so here we are. We have made it to selections. Let's go, and let's not forget to turn off the let's go. What are selection statements? These are your if statements, your if else, your if, from a Python perspective, your if, elif, else blocks. These are selections. The good news, Python and Java are so similar with respect to selections. The difference is simply the syntax and then some small nuances that we're going to cover. Jumping right in. Look, we have some Python code, we have some Java code. What are the immediate differences you see? In Python, after the condition, we have a colon, not a semicolon, we have a colon. In Java, in lieu of the colon, what do we have? We have, of course, our curly brackets. That entire block of code now has to be inside curly brackets. So all of this block of code, the statement 1, statement 2, which is indented over in Python 4 spaces, well, in Java, it's still indented over to have good style, but that block of code, as we learned, is strictly understood to be inside this if condition based off of these curly brackets. We also see in Java that we have these parentheses that are used to encapsulate the Boolean expression or that condition. Here's an if-else statement, both in Python and in Java. In Java, we have same thing. The condition has to be enclosed in parentheses. And then we have the curly brackets for the entire block of code inside the if statement as well as inside the else condition, the else statement. Notice we do not use in Java these colons that we have for Python. So normally in Python you have if, your Boolean expression, colon. In Java we have if, your Boolean expression inside parentheses, and then we have the open curly bracket. That's it. That's not a big difference. And then finally we have here in Python, we would normally have an elif statement. If you have multiple conditions, if, elif, ending with your else statement. In Java, instead of elif, we have else if. Pretty straightforward, which makes it super easy. Now, also in Java, as you know, we have data types. So we have to specify the data type. The data type for a Boolean value to hold a Boolean literal is called a Boolean data type. And the variable that holds it is called a Boolean variable. And what can you store inside a Boolean variable? Either true or false. That's it. Do notice the capitalization. In comparison to Python, where we have true and false, where the T and the F respectively are capitalized, in Java, it is fully lowercase. So as you see, we can make this Boolean variable called lights on, as just an example, where we could set it to true to signify that, hey, the lights are on. And then if they were turned off, you would set it to false. Java gives us 6 relational operators that can be used to compare the values. And the good news, once again, nothing new here. You know all of these 6 relational operators. Less than equals, greater equals, and even not equals. You know this is identical to Python. That's why we can go quickly through all of this. Here's your one-way if statement. Same logic in any programming language. If the Boolean condition, that Boolean expression, if it's true, we're going to go inside that if statement and we're going to execute the statements inside the if statement. If it's false, we're not going to execute anything. This is strictly a one-way if statement with no else block. So if it's true, we go inside. If it's false, nothing to be done. We just go to the lines of code after that block. Here's an example. What if you needed to calculate the area of a circle and you're going to ask the user to enter a radius? What if they enter a negative radius? There's clearly no area on a negative radius. So we could check first. If the radius is greater than 0 or even equal to 0, we can calculate the area, right? So we do that, we calculate the area, and then we print. And notice, just because there was no space, I put this entire print statement over, what is that? 1, 2, 3, 4 lines. Super funky, but it is allowed because when you concatenate right here, you can continue that print statement on the next line. So here, if the radius is greater or equal to 0, boom, we go inside the if statement, we compute the area, and then we print. The Boolean expression, a reminder, it has to be inside parentheses. mistakes are going to happen if we're new to Java and we're used to Python, right? That condition does not go inside parentheses. So just a reminder that Boolean expression, here we have if I is greater than 0. If this were Python, it would just have a colon afterwards, no parentheses. But here in Java, you absolutely need the parentheses. Also, the curly brackets, those block braces, those should always be used, and we'll talk more about this. They should always be used no matter what. However, it's important to just know that in Java, if you only have one line of code inside the if statement, or only one line of code inside the else or an else if statement, you don't need to use the curly brackets. Keyword, you don't need to, but you should, and we'll talk about more as to why you should. Here's your if-else statement. Same syntax, same logic that you already know, just a different syntax. If the statement, the Boolean expression, that condition is true, we go inside the if statement. If it's false, we then go to the else statement and we execute what is inside that else statement. So if the radius is greater or equal to 0, we're going to enter that if block, calculate the area, and print it. Else, we could just print a message, an error message to the user, hey, your radius is negative. You entered a negative input. Here's another example. How can you check if a number is even or odd? This is something we all know. As a Python programmer, we've certainly seen this example. How do you know if a number, an integer, is even or odd? It's even if it's divisible by 2, meaning if you divide it by 2 and the remainder is 0, then you know it's even. So how do you check the remainder in programming languages? We've learned this. We use mod. Mod gives you the remainder. So here, a simple program. If number mod 2 is 0, meaning there's no remainder when you divide it by 2, guess what? We could print numbers even, else we could print the number as odd. Pay attention to this warning. It says, notice that there's no curly brackets used, right? We said you're supposed to have a curly bracket right here, and then a closing one right here before the else, and another curly bracket after the E on the else, and then another closing curly bracket right here. We didn't use them. Why? Because I wanted to demonstrate, as mentioned, if there's only one line of code inside the if and only one line of code inside the else, you do not need to use curly brackets. However, you should, because by not using curly brackets, it can lead to errors, and we'll show you in just a few minutes how this can lead to errors. So my advice, absolutely always use curly brackets. And when you do auto formatting in most IDEs, even if you have only one line of code, it will go ahead and include those curly brackets for you. Now we're at nested if-else statements, as well as multi-way if-else statements. As you know from Python, what can go inside an if statement or what can go inside an else statement? Any legal statement, which includes another if-else statement. So we've seen before in Python that we can have an if, and inside that if, we can have another if-else, and then inside that if or that else, we can have another if-else, and this can just keep going and going and going. That inner statement is said to be nested inside the outer if statement, and this is just like Python. Here's an example. If I is greater than k, if that were true, and we enter that if block, here's another if statement. If j is greater than k, and then we have a print statement. And finally, if none of that is true, we have this else. And this else logically comes up here and it matches with this I greater than k. If that were false, if I was not greater than k, we would have come down here and we would have executed this else statement. So that inner if statement, it can contain another if statement. As mentioned, there's no limit to that depth of nesting. What's the purpose of these nested if-else statements? It's just to match the logical purpose that we'll see on many programs we're going to face, right? There's logic that we're going to be dealing with if this happens. Now, within that scenario, what if these other scenarios happen? And within this scenario, what if these scenarios? Just taking the different paths. So we have to have a logical way in code of mapping that, and that's how we can use these nested if statements. Here's another example. where we can assign a letter grade based off of the final numerical value. And this is a classical example shown on many websites and most textbooks. Look at what we have here on option A, then we'll come over here to what's in box B. So in A it says, if the score is greater or equal to 90, they got an A, like print that you've got an A. Else, what does else logically mean? It means the score is not greater or equal to 90. It's going to be less than 90. It could be in the 80 to 90 range. It could be the 70 to 80 range. It could be less than that. But that's all encompassed within this else. So here we have else, and now we have a new if statement. If the score is greater or equal to 80, well, it must be a B. And then we have an else. What does this else logically mean? It's not greater or equal to 80. It's got to be less than 80. Could be to 70, 80, 60 to 70, or worse. So now within this else, we have another if. These are all nested. If the score is greater or equal to 70, they got to see this else means it's not greater or equal to 70. It's got to be less than 70, which means it could be the 60 to 70 range or less than 60. So we have one final if-else block that is nested. If the score is greater or equal to 60, print a D. Finally, else, print an F. Nothing wrong with this code. It's a classical example of showing nested if-else statements because it's not many examples where you're going to be having this level of nested logically. Because usually when you have that, people will realize, hey, we're better off just doing what we see here in box B. And this is introducing you to multi-way if statements within Java, which are identical to what we have in Python with if, elif, else statements. So here, if the score is greater than 90, print an A. Else if the score is greater or equal to 80, print a B. Else if greater or equal to 70, print a C, and so on, just like Python. And here's the logic for this. And here's a tracing. If the score was 70, and let's just go through and see what happens as a reminder, right? This is nothing new, but no harm with a reminder. So we're going to check, is 70 greater or equal to 90? Of course not. So we're going to come to the next condition to check. The next Boolean expression. Is the score greater or equal to 80? Nope. So we're going to come to this one. Is the score greater or equal to 70? Yes, because it says suppose the score is 70. So yes, this is true. That Boolean expression evaluates to true, so we're going to go inside that statement. We're going to print the C, and as you know from Python, what happens after printing C is we come to the end of this entire block. At this point, after printing C, execution will continue after the entire logical block right here. So here's one that we could, if you want to pause the video and think about plugging in or considering the values if x is 2 and y is 3, for example. And think about if x is 2 and y is 3, what ultimately gets printed. And try that for each one of the values. I'll do, let's just say we'll start with the first one. X is 2 and y is 3. So if x is 2 and y is 3, we start right here. X is 2. Is 2 greater than 2? Absolutely not. So this initial if statement is false, right? So if this is false, we're not even going to enter into here, and we come to the else and we print the matching else statement. And you should try this as well for x equals 3 and y equals 2, as well as for x equals 3 and y equals 3. So briefly, some common errors and pitfalls. For new Java developers, the most common error with respect to selection statements is just forgetting those curly braces. The suggestion given, always use them, even if you don't have to use them. Absolutely always use them. And notice the second bullet point here. In fact, in most IDEs, as mentioned previously, when you do an auto format, it will automatically enclose those single line statements within curly brackets. Even though it's not necessary, pardon me, it will do that for you. So let me even show you here in NetBeans. This is my chapter 3 notes. Let's just say int val equals, we'll give just a number here. So if val mod 2 equals 0, right? We know that this is even. So let's just print val is even. Super exciting program. Else and we print val is odd. Now, as a Python programmer, you're going to be tempted to put a colon right there. Let me zoom in a bit more for you. You're going to be tempted to put a colon there and here, but that's not correct syntax in Java. So do not put those colons. So here, this is correct code. We run it, it's going to print val is odd. If I change val to like 8, it's going to print val is even. Pretty straightforward. The purpose, though, was not to do the code. The purpose was to show you, what if I auto-format on a PC, on a Windows-based machine? This is Alt-Shift-F, and look what happens. Even though it was valid code, why was it valid code? Because inside this if statement, I did not have curly brackets, but inside this if statement, I have only one line. And inside this else block, I have only one line. Therefore, it's valid to not put the curly brackets, but it's better to. So when you do the auto format, Alt-Shift-F, NetBeans automatically includes those curly brackets for you, which once again is my sincere advice. Wow. Always use the curly brackets, 100%. Always use the curly brackets. So here's the common error as well. So without using the curly brackets, what happens? If you said if radius is greater than 0, and then you put this code, you'll say, yeah, let's calculate the area and let's print the area. Well, what's going to happen is Java is going to assume that only this first line of code, area equals radius times pi, only that first line is part of this if statement. This second line, Java's going to assume is not part of it. For clarity, let me just erase all of this and just show you. Okay, let me do this. Let's just pretend that I had this code here. See, it doesn't even want to let me do it. Printing something else. So in my mind, let's pretend that I was expecting that all of this was going to be inside this if statement. Well, check out when I do an auto format, Alt-Shift-F. What happens? NetBeans says we're going to put a bracket around the single statement that you must have intended to be part of the if. Because again, only one statement can be inside the if you're not using curly brackets. So this statement is here, it's indented over to the right, but indentation doesn't matter in Java, right? So here, even though it's indented to the right and you might visually intend for it to be part of the if statement, but it's not, because without curly brackets, only one line of code can be inside the if statement. So when we do an Alt-Shift-F, let me do that again, Alt-Shift-F, what's going to happen is NetBeans auto formats and it puts curly brackets only around the single if statement. And then this is moved afterwards. So important to understand the need for curly braces. So here would be the correct way of doing this. Another pitfall is to maybe put colons or semicolons after the Boolean expression, which would absolutely not be correct. That would really be ending that if statement. Logically, it would be like, okay, here's just an empty block of code afterwards, and this is what goes inside the if statement. That's a common error that happens. Another common error is this dangling else ambiguity. What does this mean? Look at this code in block A right here. Notice we have 2 if clauses and only 1 else clause. So the question you should ask yourself, this else clause, which if clause is it matched with? Should this else be matched with this if, or should it be matched with this if? It's not clear unless you know the rule. Now, visually, the suggestion is that this else in the print statement to print B, within this else, the suggestion based off of the indentation is that it matches with the first if statement, but that's not correct at all. In fact, this is what's really happening in code, is that the else goes with this if block, or with this if clause. So the question, why is that the case? And here's the rule. The rule is that the else clause will always match the most recent unmatched if clause in the same block. So when you look at block A, and we see this else, and we see this else here, we say, which if does it go with? Does it go with this if or with this if? And the answer is, it goes with the most recently unmatched if. So just look up, and here, from this else, we look up, we see we have an if here. It's not currently matched with an else, well, therefore those two logically go together. That's the rule in Java. But guess what? You can avoid this ambiguity. That's why it's called ambiguity. It's confusing. You can avoid this confusion by simply using curly braces. Let's say that you wanted this else, in fact, to go with the first if. Well, by putting curly braces, now you have forced Java's hand, and now you've said, okay, this if clause, here's the opening curly bracket, here's the closing curly bracket, and therefore this else strictly comes afterwards. So the takeaway, always use curly brackets. All right. Another pitfall, those are the errors. This is the first pitfall. We have a couple of pitfalls here. So new programmers will often write code like this, and there's nothing wrong with that code. It's not an error. So this says, if number mod 2 is 0, let's set this Boolean value true, this Boolean literal true, let's set it into the variable even. Else, if it's false, let's set the value false into even, because maybe we don't want to print true or false for this particular example. Maybe we wanted to save it into this variable even to use later in the program. Nothing wrong with that code, but it's better and shorter to write it as you see on this example. Even equals number mod 2 equals 0. And usually when people see that, we're like, what? It's so confusing. It doesn't make any sense. So break it down. It's not that confusing. Just break it down. What do we see here? This ultimately is an assignment statement. In this assignment statement, where should your eyes be looking? They should look to the right. So when you look to the right, we have number mod 2 equals 0. That is a Boolean expression. That's going to evaluate to true or false. So once it evaluates to true or false, what's going to happen? That result, true or false, will then get saved into the variable even. Why is it better? Because this is a branching operation. This if-else, we call it a branching operation. And even though processors are very fast, billions of executions per second, but it's still a slow operation to do a branch. So it's better to have your code like this as a single assignment statement. Another pitfall is to avoid duplicating code when you can. If you look at this particular code block, we're doing the same print statement twice. We're printing the tuition is, and we're printing the tuition regardless of the truth of the if or the else. We're duplicating that effort. So it's better to put any common code that you find both within the if and within the else. It's better to move that to the end. So here's a checkpoint. It says rewrite the following code statement using a Boolean expression. I encourage you, pause the video and try to write this using a single Boolean expression. And I'm going to go ahead and go over to NetBeans and do the same, but pause the video and then come back and see if you get the same answer as me. So here we go into NetBeans. Let me erase this. And what do we have? We have if count mod 10, pardon me, if count mod 10 is equal to 0, so if count was divisible by 10, we're setting true into new line, otherwise we set false into new line. So new line is going to be a Boolean value, and we're basically going to set it equal to true or false, which is the result of this Boolean expression. So just count mod 10 equals 0. One line of code. Of course, it doesn't know what count is, so count would have had to have been defined previously. So end count equals 10, for example. Count equals 20. It doesn't matter. And here's our one line of code to make that happen. New line equals count mod 10 equals 0. Woohoo! I got it right. So here we have a program for us to do. Write a program that will help a first grader practice subtraction. This program should randomly generate 2 single-digit integers and should then ask a user for the answer. The program will then display a message stating if the answer is correct, or it will display a message that it is wrong, and it will print the correct answer if in fact it is wrong. So let's go. What do we do here? So the first thing is we need to generate random numbers. There's many ways we can do this in Java, and we're going to start with one of the original ways. It's not the best or the cleanest or nicest way. However, it's one of the original, most fundamental ways of doing this. It's in the math library, and we're going to get to the actual random class later. So this first approach is to just use the random method, which Java provides for you in the math class. And let me actually come over to NetBeans and show you this random method. So I'm just going to print math.random. And let's see what happens when we print this. We get a number between 0 and 1. That's it. Not from 0 to 100, from 0 to wherever. It's between 0 and 1, and it's a fractional value, right? I'm running this many times here. Here's 0.1714, 0.8018, 0.7354. And so this random method, it's inside the math class that Java provides for us. I didn't have to import anything. It's automatically accessible to us within this program. So how can we use this random method to then create a random number from 0 to 9? The way is what we're going to do is we multiply it by 10, and then we cast that floating point number as an integer. So check this out. Let me do this. If I'm going to take this random, and I'm going to actually just save it into a double. We know a double, I'm going to call it x. So I'll call it, you know what, my random number equals this. So notice I have this. I'm going to print afterwards my random number. And then now I'm going to multiply my random number by 10, and I'm going to print it again. And I just want you to see what we just did. I'm going to run that code. So the random number was, let me run it again. It was 0.1138, and now it's 1.13, right? I just basically shifted it over to the left one. It was 0.205, now it's 2.05, or 0.449, now it's 4.49. So how's that valuable to us? Well, because now we can just cast this as an integer. If I print this now, we'll see that one we had a random number of just 0.0. Let's run it again. So here it was 0.45. When I shifted it over, it becomes 4.52, and then I cast it as an integer, which I'm truncating. I'm basically deleting everything to the decimal and everything to the right of the decimal, and so I'm left with just an integer. And let me actually do that in a separate step. So let me just say int x equals, and here I'll put my random number, and then we'll print x. So here we're getting the random number. It's going to be on this case. Let me run this again. Oh, I want one that's higher than that. Here we go. 0.905. When I multiply it times 10, I get 9.05. And then I cast it as an integer. So I'm deleting the decimal and everything to the right of the decimal. I save that result into x, and here we go. To be honest, this is, if you're looking at this thinking, that's a bit confusing, and you're crying a bit, missing, Python's random. Maybe you're not crying, you have other emotions as you're missing Python's random. That's okay. Java does have a very clean random, a much nicer random number generator, which we will use. But it's important to see this one and have been exposed to it. Why? Because you're going to see it. You're going to see it outside of this program. You're going to see other people have used math.random. It's something available. So we should be comfortable with the request of knowing what math.random gives you, a number between 0 and 1. How can we mathematically manipulate that number to get the type of random numbers we want? That's something we should be comfortable to do, which is why I wanted to show it here and cover it in detail. So we need to generate 2 random numbers. That was a request of the program, right? Going back, the program said generate 2 single-digit integers, and then ask the user, this is for subtraction, right? Yeah, ask the user what's the answer to a subtraction question of subtracting that first number from the second number and then simply checking the correctness. And we do want to look at step 2 here. It says, let's make sure that number 1 is larger than number 2. Maybe, I think the storyline we could say is, hey, maybe this is a subtraction quiz for first graders. And if we ask them 6 minus 2, it's fine. Their brains can handle that. But if we ask them 2 minus 6, resulting in a negative number, they just can't deal with negative numbers. They're going to, I got to use one more. They're going to want to give up, right? They're going to want to cry about it. So we don't want to do that. We're going to ask them only to give us positive answers, or even 0 if we have 6 minus 6. So we want to guarantee that the first number within this subtraction question, number 1 minus number 2, we want to make sure that number 1 is the greater of those two numbers. And to be honest, the only reason for that request is just for us to practice using if-else to swap. Just more practicing of if-else. So then we're going to ask the question, and we're going to scan the user's answer and print whether or not it is correct. So here is some sample runs of the program. We ask what is 6 minus 6. They enter 0. We print correct. What is 9 minus 2? They put 5. We say that is wrong, and then we print the correct answer. So let's make this happen. Let me just delete this. And you know what? I want to make a new program. File, new project. Next, I'm going to call this subtraction question. And let us delete the package. Do make, please, for yourself, I encourage a new project. Don't be shy to make extra projects. You want to be able to save these things for reference and say, hey, I remember we did one like that. And you go back to it and you have all of the code ready for you. So because we need to deal with the user here, we need a scanner, right? Scanner in equals new scanner, system.in. Recall that this scanner, it needs to be imported. So add import, Java does that for me. But I'm going to go ahead and always change this to the wildcard import. And notice I called my scanner in. You could have called it Bob. It's just a variable, right? You want to call it input, fine. You want to call it scan, fine. Personally, I like to call it in, short and sweet. Makes perfect sense for me. So what do we need to do? We need to prompt the user to enter their answer to this question, which means we first need to generate those two random numbers. So here, generate two random numbers between 0 and 9. So how do we do that? Int num1 equals, we're going to cast this as an int, math.random times 10. Now, I want all of this to be in parentheses right here, right? Take the math.random, generate that number, multiply it times 10. So now we're going to have like 4.7836. We have that fractional number. Then we cast it. Had I gotten rid of those parentheses, what's going to happen here? What's going to happen is we're going to generate this random number from 0 to 1, like 0.749. We're going to cast it to an int, so it's going to always become 0, and then 0 times 10 is 0, and that would be a fail. So you absolutely want to make sure you get those parentheses in here. Left parenthesis, and we put in a right parenthesis. So let's highlight this line of code. And let's copy and paste it because it's the same line, and here's num2. And so remember, we want to ask the user, we're going to swap, but first let's go ahead and do this line of code. Prompt the user to enter their answer. So we could say int, oh no, we want to prompt them first. The comment that I just gave you. What is blank plus blank? So what is, for example, we had 8 minus 3. I'll put a colon. I don't want a question mark. I'm going to put a colon. And I'm going to put a print statement, not a print line. Then we need to scan their answer. So now, scan the user's answer. So I'm going to say int, I'll call it answer user equals, and we're going to scan it using the scanner. So n dot next int. We're scanning the next integer. We're assuming for the purposes of these first introductory programs that the user is absolutely entering correct values for us. So we scan their answer, and I typed Python syntax. Sorry, I'm used to that. Camel case, absolutely important when it's 2 words. We have the answer for the user. We scan that. And then we need to check if the user's answer is correct. All right. So now that we have this, before we prompt the user to enter their answer, we said that we want to possibly, let me do this, swap num1 and num2 only if num1 is smaller than num2, right? Because we said that we want num1. We're going to put here, this is num1 and this is num2. So check this out. Like what is, let me just put this an entire line of code. What is num1 plus a space plus num2 plus a colon? This looks hideous without formatted printing. We're going to learn formatted printing shortly. Formatted printing is a big deal, as you know, in any language, in Python, certainly in Java. This looks like garbage without formatted printing. This should have been this. It should have been, what is %d plus %d colon, and then in Python, it's like we have a dot format, right? So it's very similar in Java. You're going to see it looks very similar. But formatted printing is for another day. So we want to ask them, what is num1 plus num2? But before we do that, we want to possibly swap num1 and num2, and if num1 is smaller. So here, if num1 is smaller than num2, we need to swap num1 and num2. And perhaps you remember swapping, if you have two variables and you want to swap their contents, right? We want to basically take whatever's inside num2 and we want to save it inside num1, right? But that means we just overwrote num1. Num1 is gone. So we have to first, the first line of code is we need to make a temp variable, and we want to put num1 into that temp variable so we don't lose it. So we move num1 into temp. Then we take num2, we save it to num1, and then we save into num2 the value that we moved over into temp. Those are the famous 3 lines for swapping 2 variables. So we have generated 2 numbers. We've swapped num1 and num2 if they need to be swapped. We have prompted the user to enter their answer. We've scanned their answer. And then finally, we need to check if the answer is correct. So let us do this even. We'll do it right here. So yeah, I did answer user. So let's do answer correct as well. Let's save or compute the correct answer just to make it clean. So I'll say int answer correct equals num1 minus num2. So now to check if the user's answer is correct, I can say if answer user equal answer correct. So if they are the same, what do we want to print? We want to print nicely done, you are a rock star. Else, we want to print what? See, when I do this live with students, they give me nasty messages to give to these first and second graders, which is so horrible. Have mercy. We want to say that is not correct. Better luck next time. And now let's print the correct answer. The correct answer is answer is as follows. And I'll do this on a single line. How about I put some starting 4 spaces, and then I'll say num1 concatenate a space, concatenate. I just realized I needed a minus sign here and a minus sign here. So num1, we print a minus, then we put num2, then I concatenate. Oh, this is hideous, all this non-formatted printing output. It's hideous. Now we're going to concatenate an equal sign, and then we're going to concatenate answer correct. Let's see if that all works. I think it should. Let me come down here just a little bit so we can see the whole program. And let me zoom out some a little bit. There we go. So here is our program. And let's run this code. Let me zoom up some, scroll up some. What is 9 minus 3? Let's put a correct answer, 6. Nicely done. You are a rock star. What is 1 minus 1? They put the incorrect answer. They put 1. That is not correct. Better luck next time. The correct answer is as follows. 1 minus 1 is 0. What's 5 minus 0? 5. So notice we never get a negative number, right? Because we did that swapping. What is 8 minus 2? 6, right? What is 9 minus 6? 3. Had I removed this swapping, the only purpose of the swap was, I said, to practice more if else. But had I removed that, of course, we'll get negative numbers every now and then. What is 8 minus 5? That was a 3. Let's run this again. What is 4 minus 5? So here now we have to enter a negative 1, right? So it was just to put in some extra layer of practicing with if and else. Hopefully that is clear. Here's a solution in the slides from the publisher. So this is a good checkpoint. I would go through these one at a time. Like, how do you generate a random integer I between 0 and 10, not including 10? That's the one we just did. What about this one? How do you generate a random number I such that I is between 0 and 20, not including 20? Well, that's going to be multiplying it by 20. That's easier. But what about this? How do you generate a random number I such that 10 is less than or equal to I, and then I is less than 20, but we're not counting 20? So how would you do that mathematically? You got to think about this. It's a little bit of problem solving. So how many different numbers do we want? We want 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We want 10 possible numbers between 10 and 19, including 19. We want to generate one of those 10 possible numbers. So what you do is this. You do that same logic. You generate a random number from 0 to 9, which is 10 possible numbers, and then you add 10 to it, which is super funky, right? Which is why I said this is not the nice way of generating random numbers. We absolutely will show you a better way, but you need to have been exposed to this, and you need to make sure you understand how to solve that type of a question. How do you generate a random number between 10 and 50? Write an expression that returns 0 or 1 randomly. Here, it's just going to be you multiply it times 2, and then you cast it as an int. All right, logical operators. We're almost done with selections. The logic of connecting these Boolean expressions is the same in any programming language, logically. The difference, syntax. And here, Python is the absolute winner. Why? Because it's just so clear in Python. Python, we literally have and, the keyword and, for and, logically. And we have the keyword or for the logical or. In Java, we have this. It's 2 and sign. This is shift 7. We have 2 shift 7s. That is the and for Java. The or for Java is this, which is above the enter key on the backslash. It's shift backslash. It's this vertical line. And 2 of them next to each other. There's no spaces between them. No spaces. No spaces between these ampersand. 2 of them next to each other of the ampersand is an and in Java, and 2 of them next to each other is an or. And then finally, also Java does not have the not keyword. Instead, it's just an exclamation point, which means not. And you've seen the exclamation point when you've done, let me come back to garbage, right? If I were to say int x equals 3, how about, no, let me do this. Boolean x equals true, right? We can print x. Or what if I want to print not x? That'll simply print false, right? We get true and we get false. So in Python, yeah, we could have just said not x, which is so much clearer to be able to use English commands instead of an exclamation point. So here, Python's the absolute winner. This is just a caution that the following would not be correct, not in Java, not in Python. So here, if we say 1, if you want to like confirm, ask the user to enter the number of days in the month, and you want to make sure they entered a number between 1 and 31, you cannot write syntax like this because this less than equals, it's part of a Boolean expression. So when you see right here, let me actually just draw this out with a pen. This right here, this right here, that needs to evaluate to true or false, right? And then this as well needs to evaluate to true or false. And that doesn't work on the example that we're seeing here. So instead, let me come grab the pin again. Here, come on, pin. So here, this will evaluate to true or false. This will evaluate to true or false. So we're getting the truth of both of those. Is the day that you entered, is it greater or equal to 1? Cool. Is it less than or equal to 31? Great. And then we do what? We use the and to confirm that ultimately this was a true value entered. Was the first thing true, greater or equal to 1? Perfect. The second thing true, less than or equal to 31? Fantastic. We are now good to go and the whole thing is true. You've learned this in Python, but it's a good reminder to see that again. Here's a checkpoint. We're going to go through these just by showing them on the screen. I would encourage you to pause the video, make sure we understand why these are all true or false. This is your and again, this is your or. How about we even just look maybe at the last one in case it's more complicated. So here we have an equal sign. We want to check, is this left side equal to the right side? The answer is true. Let's confirm that. So they say that x is 1. So let's plug in 1 for x on both sides. We start on the left. If x is 1, 1 does not equal 1. That's a false statement. So this here is false. And now we have x equal 1. 1 does equal 1. That's a true statement. And not true is false. So ultimately we have here what? We have false equal false. That's a true statement. False does equal false, which is why it's true. I encourage you to go through all of those for practice. And here's some good practice. Write a Boolean expression that evaluates to true if a number stored in the variable num is between 1 and 100. So we said if we have a variable num, let's just say it was 72. And they said write a Boolean expression that evaluates to true if a number stored in num is between 1 and 100. So I'm just going to write the expression. I'm not going to even make a variable. So if it's between 1 and 100, let's pretend inclusive of 1 or 100. So I could say if 1 is less than or equal to num, and num is less than or equal to 100. So we're saying that, num is greater or equal to 1. So 1 is less than or equal to num, and num is less than or equal to 100. This would be a Boolean expression to solve that. And that is what I just coded. Cool. I got it right. Write a Boolean expression that evaluates to true. Let's go. I want to get to the let's go because I got it right. Write a Boolean expression that evaluates to true if a number stored in variable num is between 1 and 100. Or if the number is negative. So now we want to write a Boolean expression that evaluates to true if all of this is true, or if the number is possibly negative. So if this were Python, we'd say, or if num is negative, if num is 0, right? So how do we do that in Java? There is no or. You need to put, that's the or, right? And now here we have a Boolean expression, and here we have a Boolean expression, but that all needs to be inside one pair of outer parentheses. And now we get what we need. And that would be the answer. All right, switch statements. This is going to be new for us. What are switch statements? We're about to find out. So nested if statements are very helpful. They allow us to translate our logical conditions to code. But when we have an overuse of these nested if statements, it can be difficult to read. So Java gives us what is called a switch statement. Super cool, allows us to code multiple conditions, but it's really just a new way to have an if, else if, else block. So here's an example. We have switch based off of something here, and I'll break this down. And for example, this could be an integer value. And let's say that integer value could be between 0 and 3. So we then have cases for that switch. If it's a 0, we put the code for case 0. If it was a 1, we put the code for case 1. It'd be like, if it's 0, we put the code inside there. Else if it's 1, we put the code inside the else if block. Else if it's 2, we put the code inside that block. That's the same thing as this case 2 and then the case 3. So status, I said here, is just an integer representing some user's choice. So this switch statement, what it does is it checks to see whether status matches this value, 0, 1, 2, or 3 in that exact order. This should be a 2 here. If the status matches the value, the code for that particular case is executed. Then, just like a regular if statement, we want to skip all of the rest of the code, and that's what we do with that break statement that you see after each one. This will break us out of the remainder of that switch block. And here's a flow chart to show us what's going on. So let's say the status was not 0, it was not 1, but let's say the status was equal to 2. We're going to do the code for that block, like else if it was 2, we do the code inside the else if block, and then we end the entire else if block. So in a switch, we want to break completely out of the switch. Here's the overall syntax for a switch statement. We're going to switch based off of some expression, and it's going to be an int, a char, even a string. There's various types of values we can put there. And then we're going to have many cases of our expectations of what this switch expression was, and we're going to go through this. And we have many examples to go through. So this switch expression, it has to yield a value, a char, a byte, a short, an int, or a string. And we're going to cover more on chars and strings on the next chapter. Switch expressions, they always have to be in parentheses, as we see here in the syntax. That value 1, 2, all the way to value n, they have to have the same data type as the switch expression. And notice that value 1, value 2, value n, those are constant expressions. They cannot be a variable. They have to be constants. When the value in a case statement matches the value in a switch expression, the statements will then be executed starting from that point, and will keep executing unless we have a break statement. Now, as I've gone through that, any listener, even if you're fully with me, you should have been a bit confused, right? That makes sense, which is why we're going to have some samples to follow and make sense of all of this. I skipped those last two. I might come to these slides, but it's going to make perfect sense once we go through these. So here's a switch. Pardon me. We say int a equals 1, and now we're going to switch on that value a. Now, we can see here that a is 1, but what if the user had entered a, right? We don't know what a is. But in this example, we know strictly that a is 1. So we're going to switch based off of the value inside the variable a. So we come to the various cases. We say, hey, what if we're at case 1? Well, case 1 is matching what a is. A is 1, so case 1 is true. So now we're going to execute the code that is part of case 1, and we're going to print this statement with the word 1 inside. Now, here's what's weird on this example, but we're still going to print 7, and we're still going to then print 3, which is kind of weird. You might say, but a was not equal to 7, a was not equal to 2, a was equal to 1. That's correct. A was equal to 1, which brought the logic, because we're basically going to go down here in this direction. But as soon as one of these is true, we step over to the right of the colon, and we start executing, and we go down, and we keep going down if there is no break statement. So here, and we're actually going to print 1, then 7, and then 3 because there's no break statement. Compare that to this one. Well, and then after we finish, right, we finish the switch and we're done. Compare that to this now. A is still 1. So we're switching based off of the value in A, which we know is 1 because we assigned it to 1 at the top of this example. And we're at case 1, that's true, so we're going to step over here and we're going to print 1, but now we break, which is usually what you're going to want to do because this now matches with an if-else statement. And when we break, this is going to bring us outside of the remainder of the switch block, right? We're going to exit the switch block and we're going to go on to the next statement. Here's another one. What if I wanted to switch based off of the value 10? So we look at the various cases. Case 1, nope, that's not 10. Case 7, that's not 10. Case 2, nope, that's not 10. So we don't enter any one of these. Again, this is just like an if-else. So this would be like, if A is 1, no. Else if, is A is 7? No. Else if, A is 2? No. Else would be our default. So switches have a default, which is just like an else statement. And here we could print an error. It's just a default option. You can just print whatever you would normally want to print inside an else block. We can also switch on a char value. Remember, a char is a primitive data type. We can switch based off of a char val. So here we have switch based off of the variable ch, which is a char that we assigned the lowercase letter a. And here's our case. Case lowercase a, yep, it's already true. So we're going to print the value in ch, which is an a. But because there's no break, we're going to come to the next print statement, which does what? It prints a again. The next print statement prints a again. And then we're done with the switch. Compare that now to this. We're switching on what's inside ch, which is still a. And we now come to this case a, which again, it's like an if-else. So this is really saying, here on case a, it's really saying, if ch equal a. It does. So we're going to print ch. We're going to print the a, and then we're going to break. So it's really just like an if-else. It's just another type. Here's another example. Suppose the day, the variable day, we ask the user enter the day of a week from maybe 0 to 7 or something. 0 to 6, sorry. They enter 2. So we're going to check. Case 1, nothing. Case 2 is true. So then we're going to move over here. Notice there's no code, but that's okay. But there's no break either. So it would fall down all the way to case 5, because not because case 5 is true, because once 2 is true, we're now going to be on the right side, and we're going to be looking for code. There's no code. There's no code. There is code here, and we print weekday, and then we break. So the output is weekday, and we break. So the example that I've seen in many textbooks, I don't know why, maybe publishers are excited about the Chinese zodiac. I remember seeing this only at restaurants growing up, you know, right in front of you on your next to your plate, the zodiac, you know, and go read, oh, I was born in the year of the tiger, or what have you. So this says, write a program that will determine the Chinese zodiac for a given year. Specifically, your program should prompt the user to enter a year. The program should then determine the zodiac and display the results. Now, the purpose of giving this program is because there's 12 possibilities. If you're familiar with the zodiac calendar, or the zodiac, Chinese zodiac, there's 12 possibilities. And in fact, it's determined by taking year and modding it by 12. If you didn't know that, some of you are going to like immediately pause the video, pull out a calculator, mod your year, divide your year by 12, look at the remainder. Sure enough, that is the correct answer. So it's that simple. Take the user's year, mod it by 12. If the answer is 0, the remainder is 0, you're born in the year of the monkey. The answer is, you know, for example, 10, you're born in the year of the horse, 11, year of the sheep, and so on. It's a pretty straightforward program. Here's a solution. And the reason why it's given is because this is a great example of when you'd want to use a switch statement. You could absolutely have done this exact same program with an if-else. So what do we have here? We have a year mod 12. So let's say year was equal for many of you, probably 2000 and I'm going to guess 3 or 2, many students in here who are watching this video, year equals 2002 maybe when you were born. And let us now do an if-else statement. So if year mod 2, year mod 12 equals 0, what does that mean? We're going to print you were born in the year of the monkey. Cool. Now we're going to have what? Just a lot of else if. So else if, this would be 1, and this would be rooster. Just follow me here. That's That's for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the final one would be else. This should be 10 if I did that correct. Else you were born in the year of the sheep. So this was horse for 10. And this would be you were born in the year of the sheep. And then we would just go change all these values, right? This is going to be a 2. This is a 3, a 4, a 5, a 6, a 7, 8, 9, 10. And just go fill all of these out from rooster, dog. So we have dog, pig, rat, ox, dog. May as well finish it. Pig, rat, ox, and then you got a whopping 4 more. I won't even type them in. But you see, here's the code. It's not that bad, but this is a great example of when a switch would be nice. And what does Java do right here? It says replace chain of ifs with a switch. Convert ifs to a switch. Check it out. That is pretty cool that it did that for you. Case 0, you're born in the year of the monkey, and then we break. Case 1, year of the rooster, and break. And this is the correct formatting as well. So on the slide, they were showing this case 0 on the same line as the colon, putting the print statement in break. It's no harm, no foul, but it's not clear, right? Clarity is what's most important in software engineering, software design. We want clarity for the developers, for your teams that you're going to be on. And so this is very clear. And we finally get down to case 10, the year of the horse. Next would be case 11, but there is no other option, right? Because when you mod something by 12, there's going to be 12 possibilities from 0 to 11. There's no other possible remainders when you divide by 12, right? If you divide by 12, the remainder could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can't have a remainder of 12. So we have the possibilities from 0 to 11. So therefore, yeah, this default, it's kind of like that else that we had. That's your default. Now do notice here, I'm not covering this in the slide. This is newer in one of the newer versions a few years ago of Java. Convert to what is called a rule switch, which is a different type of switch that I won't cover, but wanted to show you that even this is available, and it's another newer type of switch in Java. So a rule switch, I'm hitting Control Z to go back to the previous switch. And then if I do Control Z, now I'm back in my if else. So it's really nothing other than another means of doing an if else. But once you're used to it, there are use cases. And this problem was a perfect use case of a switch statement. It just feels cleaner than doing this long convoluted if else statement. So the final thing that we have here is conditional expressions. And this is cool. It's maybe nerdy, but it's nice. So you're going to see often we're going to have a situation where you might want to assign a value to a variable based off of a particular condition, such as we see in this code below. If x is greater than 0, save 1 into y, else save minus 1 into y. Hypothetically, like, why do we have this code? It's just an example. But you'll have many situations where you're going to save something into a variable strictly based off of a condition. When you have that situation, you can actually use what is called a conditional expression. These 4 lines of code can actually be written with this one single line, which is really funky. This is absolutely one where I'm going to leave it on the screen. It's worth it because this looks damn confusing. Y equals x greater than 0, question mark, 1 colon minus 1. What? Anytime you see a question mark, anytime, in code like this, you know that means look to the left of the question mark, you should have a Boolean expression. Evaluate that Boolean expression. The result is going to be true or false. If it's true, take this value, the one that's to the left of the colon, and save it to y. If it's false, take this minus 1 and save it into y. That's the syntax. It's not too confusing. You don't want to use it. You don't have to. It's a nerdy thing to do, but check this out. Given two numbers, num1 and num2, save the larger of those two numbers into the variable max. So if I come delete this, I wouldn't delete, I would just save that code and put this afterwards, or hopefully you put that, I didn't realize I was using the garbage program here. Hopefully you put that inside just a Chinese Zodiac. You know what, I'm gonna do that since I did most of the code. File, new project, next, Zodiac, delete the package, finish, and paste. Cool. And just do an Alt-Shift-F anyway. Make sure it's formatted. Always do Alt-Shift-F, right? Always. There is no reason not to be doing this. So I'm just going to tab everything, all kinds of funky, right? All kinds of weird spacing. As soon as I do an Alt-Shift-F, boom, fixes it all. All right, so I've saved that code. Now I've saved the code. Let's come back here to Chapter 3 notes. And what did the problem say? The problem said, given two numbers, num1 and num2, what just happened? That is funky. Okay. All right, I don't know what's going on. I was about to be very confused myself. So num1 and num2, right? We have given two numbers, num1 and num2, save the larger into a variable called max. So let's say we had num1 equals 8, num2 equals 6. We don't know what they are. Imagine we ask the user to enter those values. So I would say int max equals, one line of code. Normally you would do this. We'd say if num1 is greater than num2, let's say we had defined a max above, we have int max. So if num1 is greater than num2, we want to say max equals num1, else max equals num2, right? Those are, what is that, 6 lines of code to make this happen. Or we could have just said max equals, I do num1 greater than num2, that's a Boolean expression, and if it's true, I'm going to save num1 inside max, otherwise I'm going to save num2 inside max. That's cool. It's nerdy. It's honestly something that only a certain type of student or developer normally uses because you know code very well. I think it's cool. Here, another example, given a variable num, display the message num is even, if num is even, otherwise display num is odd. So absolutely this code is just fine, right? I can say if num mod 2 is 0, print it's even, otherwise print it's odd. Or a single print statement. Check that out. If num mod 2 is 0, that's a Boolean expression. Now we have a question mark. And remember, this is just a print statement. So really we're trying to print. I'm trying to print either num is even or I'm going to print num is odd. Which one am I going to print? Well, I have that question mark, which tells you, oh, this is that conditional expression thingy, that weird, that funky thing that he showed us. Well, yeah, we're going to print num is even or num is odd based off of the result of this, which is going to be true or false. If it's true, we print num is even. If it's false, we print num is odd. Here's one more example. I'd encourage you to pause the video, see if you can code this up yourself, and here's the solution for ticket price. If the age is greater than or equal to 16, the ticket price, we save 20 to ticket price. Otherwise, we save 10 into it. The last thing on the slides is just talking about operator precedence. This is something we've learned since elementary school from the PEMDAS rule, parentheses, exponent, multiplication, division, addition, subtraction, right? The operator precedence. So those are things we know, but we have these rules of precedence for this. Here's this entire chart. This is something you have to just learn. Much of this we already know for multiplication, division, remainder, addition, subtraction. But what about when you now include the and, the or, augmented operators, when you include not? And this is true for Python. If I give you a long convoluted expression, what gets evaluated first? You have to know the rules of precedence for this. Always parentheses, what's inside parentheses gets executed first. And then operators are going to be applied in the order of their precedence role as well as their associativity role. So if you have two operators that are on the same level, so for example, imagine you have plus and minus, which one is evaluated first, the plus or the minus? If they're within the same block, the same level of parentheses, we have the left associative role. We go from left to right. So all binary operators except the assignment ones are left associative. So here are some examples of operator precedence. That is it. This is a 70-minute video. Have fun consuming it. Reach out if you have any questions at all. Leave a comment, ask questions. Let's go. We made it through successfully. Take care, everyone.